The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All righty, let's see here. So, first of all, let's do a quick review of what happened yesterday. Yesterday, we looked at equations in the form y equals a times x minus h squared plus k. If a was positive, greater than 0, we had a parabola that opened upwards. If a was negative, less than 0, we had a parabola that opened downwards. The axis of symmetry, which is a vertical line that goes through the vertex and is sort of the folding line for the parabola, is an equation x equals h. You have to put x equals. You can't just put the number. And the vertex of the parabola is at hk. When you graph parabolas in WebAssign, you need to graph the vertex first and then one other point on the parabola. All right. Anyway, now I'm going to pause the well, actually, let's keep going and we'll change things up in a minute here. So today we're going to look at a different form of a second degree or quadratic equation, and that is y equals ax squared plus bx plus c, which is more like what we use when we use the quadratic formula. When we have an equation in this form, the axis of symmetry is at x equals negative b over 2a. And the vertex is at negative b over 2a, so the same x value. And then the y value would be whatever we get after we put the x value in, so f of negative b over 2a. Okay, the a is the same a as in the other form. So if a is greater than 0, the parabola opens, upwards. If a is less than 0, the parabola opens downwards. All right, and we're going to go through all that in a little bit. In addition to that, we're going to look for x and y intercepts. How do you find an x intercept? To find an x intercept, set y equal to 0. So in other words, complete that ordered pair. To find a y-intercept, set x equal to 0. So complete that ordered pair. All right, I'm going to pause the recording and switch screens around here. All right, we'll start the recording back up again. And now we can look at the whiteboard and WebAssign at the same time. So let's take a look at problem number 24 over on the the left side of the board. It says find the x and y intercepts of the graph of the quadratic function. So we have, let's see here, it's not working yet. Okay. Here we go. We have the quadratic function f of x equals x squared minus 2x minus 35. All right, we said to find x-intercepts, set y equal to 0. Well, if we set y equal to 0, we get this. That should look familiar because that's the form we have an equation in when we use the quadratic formula to solve for x. Y is 0. So using the quadratic formula, a is 1, b is negative 2, and c is negative 35. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Going on and simplifying, x equals positive 2 plus or minus the square root of 4 plus 140. Negative 4 times 1 times negative 35 is going to be positive. So then we get all of that over 2. X equals 2 plus or minus the square root of 144 all over 2. X equals 2 plus or minus, well, the square root of 144 is 12 all over 2. So X equals 2 plus 12 over 2, which is 14 over 2 or 7. X equals 2 minus 12 over 2, which is negative 10 over 2 or negative 5. So X is 7 and negative 5. So our X-intercepts would be negative 5, 0, and 7, 0. Now, note that over in WebAssign, it says to write the smaller X value first. Negative 5 is smaller than 7. So our first ordered pair, we're going to have negative 5, space 0, 7, space 0. In the past, I've had students just put in the non-zero values, just the X values, and it got marked wrong. This needs to be an ordered pair, okay, including the 0. Now to find the Y-intercept, let's go back over here. And again, we've got f of x equals x squared minus 2x minus 35. To find the Y-intercept, we set x equal to 0. So f of 0 would be 0 squared minus 2 times 0 minus 35, or just negative 35. So our Y-intercept is at 0, negative 35. When the equation is in this form, the Y-intercept is always going to be c, the constant, because these two terms contain x, which will then go to 0. So over here, we have 0, space, negative 35. And let's see how we did. All right, let's take a look at another example of the same thing. So here we've got, let's see, let's switch over to black ink. I just prefer that. So we've got f of x equals negative x squared minus 10x minus 9. So to find x-intercepts, set y equal to 0. So 0 equals negative x squared minus 10x minus 9. A is negative 1, B is negative 10, and C is negative 9. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 10 plus or minus the square root of 100 minus 36 all over negative 2. X equals 10 plus or minus the square root of 64 all over negative 2. X equals 10 plus or minus 8 all over negative 2. X equals 10 plus 8 over negative 2, which is 18 over negative 2 or negative 9. X equals 10 minus 8 over negative 2, which is 2 over negative 2 or negative 1. So x equals negative 9 and x equals negative 1. Our ordered pairs, negative 9, 0, negative 1, 0. Again, the negative 9 would be the smaller value. If you're wondering, why didn't I take this equation and multiply both sides by a negative 1 to make my leading coefficient a positive 1? I could have done that. That would have been a good move. I just didn't bother, but certainly would have been a good idea. All right, so our x-intercepts are at negative 9, 0, and negative 1, 0. Y-intercept. F of x equals negative x squared minus 10x minus 9. F of 0 is going to be negative 9, as I said before. So y-intercept at 0, negative 9. And let's see what happens. All right, the next thing I want to do is we're going to graph a parabola using the new formulas that I gave you. Where is it here? I guess I deleted it. Anyway, the negative b over 2a, all of that stuff. We'll talk about it. Okay, so we've got the following function. F of x equals x squared plus 8x plus 16. We're supposed to find the vertex. Well, this function, this equation, is in standard or descending powers form. So a is 1 and b is 8, c is 16. To find the axis of symmetry, that is at x equals negative b over 2a. Now, you might be saying, well, it didn't really ask us to find the axis of symmetry, and you're right. But to get to the vertex, we have to go through the axis of symmetry. We have to find it first. So that's because that's going to be the x value of the vertex. All right, so this is negative 8 over 2 times 1, negative 8 over 2, or negative 4. So x equals negative 4 would be the axis of symmetry. So now the vertex is at negative 4 comma f of negative 4. Well, let's find out what f of negative 4 is. In other words, we're going to put negative 4 in the place of x to find the corresponding y value. Now I'm getting 0. Okay, so it looks like the vertex is at negative 4, 0. So negative 4, comma, space, 0. Now, X-intercept. All right, so we're going to go back here. F of x equals x squared plus 8x plus 16. To find the X-intercept or X-intercepts, set y equal to 0. Okay. Then we're going to use the quadratic formula. So here we go with a is 1, b is 8, and c is 16. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 8 plus or minus the square root of 64 minus 64 all over 2. X equals negative 8 plus or minus the square root of 0 over 2. X equals negative 8 plus or minus 0 over 2. X equals negative 8 over 2, which is negative 4. No wonder it just said X-intercept, because we really only have one unique X-intercept. It appears twice, so it's a multiple 0, but still x equals negative 4. So the X-intercept would be negative 4, 0. Look at that. The vertex and the X-intercept are the same value. So that means that the vertex lies right on the x-axis. Okay, going on, we need to find the Y-intercept. So f of 0 is going to be 0 squared plus 8 times 0 plus 16. So the Y-intercept is at 0, 16. Again, it's going to be that value. Okay, 0, comma, space, 16. Now, just like when graphing parabolas in that other form, the y equals a times x minus h squared plus k, when we're graphing parabolas in this form, f of x equals ax squared plus bx plus c, we're going to graph the vertex first, and then one other point that's on the graph that's not the vertex. All right, so we're going to click this till it's blue. Negative 4, 0. Notice our scale, each square is 2 units, so negative 4 zeros right there. I already have other points. Well, the X-intercept is the same point as the vertex, but I could use the Y-intercept, so I don't need to calculate additional points. 0, 16 is right there. And let's make sure we've got our points, -4, 0, 0, 16. And we'll submit that answer. And it is correct. Woohoo! All right, so we got the vertex, the X-intercept, the Y-intercept. Let's do another one. Let's see here. Let's do this one. All right. Actually, I want to do, let's see if we can find one that has more than one X-intercept. Well, I guess not. That's all right. Let's do this one. Okay. So we've got f of x equals -6x squared minus 12x minus 32. A is -6, B is -12, C is -32. The vertex, well, first of all, I'm going to find the axis of symmetry is at x equals -b over 2a, which is negative times -12 over 2 times -6, which is 12 over -12, which is -1. So the axis of symmetry is at x equals -1, and the vertex is at -1 comma f of -1, which is -6 times -1 squared minus 12 times -1 minus 32, which is -6 times 1 plus 12 minus 32, which is -6 plus 12 minus 32. Oh, let's see, that's going to be what, -20 something or other. My brain's not awake. Let's see, we've got -6 plus 12 minus 32 is -26. Okay, so our vertex is at -1, -26. Okay, X-intercept, or X-intercept it says. To find the X-intercept, we're going to set y equal to 0. I'm going to go ahead and use what I already found, and that is, if I set it equal to 0, 0 equals -6x squared minus 12x minus 32. A, B, and C are right there. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals 12 plus or minus the square root of 144 minus, let's see here, 24. That's not going to come out right. So hang on a minute. Well, I started to panic, and it turns out I didn't need to panic. I forgot that this course includes things that we don't really talk about a lot, but we'll talk about it a little bit here. So what's going to happen right here when I take -4, let's see, I've got -4 times -6 times -32, and I get -768 all over -12. Now, that gives me 144 minus 768. Here's why I panicked, because now I'm going to take the square root of a negative number. And we can't do that and get a real number. But I come back over here and I look at, it says the directions. Determine the coordinates of the vertex of the graph of the function using the vertex formula. That's what we're using. Then determine the x and y intercepts of the graph. If an answer does not exist, enter D in E. So I'm going to put in D in E. Why? Because it doesn't exist. Now, how can that be? How can there not be any X-intercepts? And again, notice I'm using capital letters, don't use lowercase letters. Well, let's go on and finish this problem and see what's going to happen here. So to find the y-intercept, we've got f of x equals negative 6x squared minus 12x minus 32. So f of 0 would be negative 32. So the y-intercept is going to be at 0, negative 32. Okay. Oh, look at here. Our scale, our squares are in units of 4. That's going to be tricky. So the vertex is at negative 1, negative 26. Well, negative 1, negative 26 is right about there. It's not going to let me look at that yet. Y-intercept is at 0, negative 32, so I'll put that right there. And let me check my points. Okay, it says negative 1, but I need negative 26 for the x value. So that matches the vertex. And then 0, negative 32. Okay, let's see what happens. Let's see if that says it's correct. Well, what do you know? It's correct. Now, why is there no x-intercept? Well, look at where the vertex is. It's right here. Okay, it's below the x-axis. And since A is negative 6, it opens downwards, so it doesn't cross the x-axis. So there's no x-intercepts. Likewise, if you had a graph where the vertex was above the x-axis and it opened upwards, you'd have no x-intercepts. Well, how does that work out in terms of the quadratic formula? When this, which is the stuff underneath the radical sign, when that's negative, we're taking the square root of a negative number. That's not a real number. It does not exist. That's what happens on the graph. All right. So now we're going to pause again, and I'm going to switch back to the other. Okay, we're back. Now we're going to look at some application problems using second degree or quadratic equations. And these story problems are going to involve a maximum value or a minimum value. Well, graphically, if you have a parabola that opens upwards, the vertex is at the low point, so that would be a minimum. If it opens downwards, the vertex is at the top, so that would be a maximum. So the y value here is a minimum, the y value there is a maximum. All right, let's see how that's going to work out. Okay, this problem says operating costs. The cost C in dollars of operating a certain concrete cutting machine is related to the number of minutes N the machine is run by the function C of N equals 2.2N squared minus 66N plus 655. So in this equation or function, N is the number of minutes that the machine is run, and C, or C of N, the output, is the cost of running the machine for that number of minutes. It says, find the number of minutes, or excuse me, for what number of minutes is the cost of running the machine a minimum, and what is the minimum cost? All right, if we look at this equation, we see that A is positive, which means our graph is going to open upwards, which means our vertex is going to be the minimum, okay? So if we find the N and the C of N of the vertex, the N will give us the, let's see, where is it here? Give us the number of minutes producing the minimum cost, and then the C will be the minimum cost. So basically it's all about finding the vertex. So let's do that. Well, let's see. A is 2.2, B is negative 66, okay? And C is 655. I keep writing that there even though we don't need it for this part of the problem. So technically we're finding n, but I'm going to still just use x equals negative b over 2a. That's going to give us the axis of symmetry, negative times negative 66 over 2 times 2.2, which is 66 over 4.4. And let's see what that is. 66 divided by 4.4 comes out to 15. C of 15 equals 2.2 times 15 squared minus 66 times 15 plus 655. Let's see here. 2.2 times 15 squared minus 66 times 15 plus 655 equals 160. So the vertex is at 15, 160. So number of minutes equals 15 and cost equals $160. So 15 minutes is the minimum, is the time to achieve the minimum cost, and that minimum cost is $160. All right, let's take a look at another problem. It says fireworks. A fireworks shell is shot straight upward with an initial velocity of 120 feet per second. Its height, s, in feet. I don't know why they use s for feet, but they do. And t, after t seconds, is approximated by the equation s equals 120t minus 16t squared. Now, t is time in seconds from the time that the fireworks is shot, and s is the distance above the ground, so the altitude, okay? If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? All right, first of all, let's put this equation in descending powers form, okay? We see that the leading coefficient is negative, so our graph is going to open down. So the vertex is going to be the high point. So our ordered pair for the vertex, t comma s, t will be the time it reaches the high point, and s will be that maximum height. So it says how long after being fired, that's the time, and at what height, that's the distance, will the fireworks appear in the sky. So once again, we're looking for the vertex to answer the two questions. All right, so using this standard form of it, we have a is negative 16 and b is 120. C in this case is 0. X equals negative b over 2a, negative 120 over 2 times negative 16, negative 120 over negative 32. And let's see, negative divided by negative is positive. 120 divided by 32 is 3.75, so that's seconds. So that's how long it takes for the fireworks to reach the maximum height. To find that maximum height, we need to put what? 3.75 in for t. So s equals negative 16 times 3.75 squared plus 120 times 3.75. Go to the calculator. Negative 16 times 3.75 squared plus 120 times 3.75. And I'm getting 225, and that would be feet. So let's see here. How long after being fired? 3.75 seconds. And what is the height at which the fireworks will appear in the sky? 225 feet. And again, 3.75 comma 225, that would be the vertex. Okay. Another example. Projectiles. A ball is thrown straight upward from the top of a building with an initial velocity of 32 feet per second. The equation S equals -16t squared plus 32t plus 48 gives the height S of the ball in t feet, or in feet, t seconds after it is thrown. So again, t is time in seconds, S is the height of the ball in feet. Find the maximum height reached by the ball and the time it takes for the ball to hit the ground. So slightly different questions here, okay? We've got this building and this ball is thrown up and then it's gonna hit the ground here. Let's see here, there's our ground down here. Okay, so they wanna know the maximum height. So that's gonna be an ordered pair, but they want the height. And then they wanna know the time when it hits the ground. So in the last problem, they want to know the time it reached its maximum height. Here, they just want the maximum height and they want the time when it hits the ground. Okay, so how's that going to work? So to find the maximum height, we need to find the y value of the vertex. Okay, and let's see, we're going to use x equals negative b over 2a, and a is -16 and b is 32. So this is going to be -32 over 2 times -16, which is -32 over -32, which is 1. Okay, so it reaches the maximum height 1 second after being shot off. We don't need that, but we do need it to get to the height. So now we've got S equals -16, 1 squared plus 32 times 1. When I said we don't need it, they didn't ask for it, but we needed to find it. Plus 48, -16 times 1 plus 32 plus 48. -16 plus 32 plus 48 is 64. So this is 164. So after 1 second, it reaches the maximum height of 64 feet. So maximum height of 64 feet. Okay, that was the first question. It said find the maximum height and the time it takes for the ball to hit the ground. Now, how do we find that? Well, when is the height 0? When it's on the x-axis. So now we're looking for the x-intercepts. How do we do that? We set y equal to 0, or in this case, s, the distance. So I'm going to take this and write it on the next page so I have lots more room to work with. S equals -16t squared plus 32t plus 48. Is that correct? Okay. And I want to find when it hits the ground. So 0 equals -16t squared plus 32t plus 48. You know what? I could factor a -16 out of that and get that, couldn't I? Think so. Divide both sides by -16. So basically, I've reduced down the equation I'm going to use for the quadratic formula. A is 1, B is -2, C is -3. T equals -b plus or minus the square root of b squared minus 4ac all over 2a. T equals 2 plus or minus the square root of 4 plus 12 all over 2. T equals 2 plus or minus the square root of 16 over 2. T equals 2 plus or minus 4 over 2. T equals 2 plus 4 over 2, which is 6 over 2, which is 3. T equals 2 minus 4, excuse me, not -2. Slow down. Over 2, which is -2 over 2, which is -1. So T equals 3 and T equals -1. Let's take that and go back to the previous page. So here, T is, oops, that's not the right one. T is 3. Now, if we were to continue this down to the graph, or down to the x-axis, this is where you'd have your -1, but you can't have negative time. You might be having a bad time right now, but it's not technically a negative time. So what does that mean? It means this value doesn't work for the problem. So when does it hit the ground? 3 seconds after launch. Or is that after lunch? Not quite. All right. So maximum height of 64 feet, hits the ground 3 seconds later. But again, this was different from the previous problem. We used the vertex formula to get the maximum height, but we used the quadratic formula to get when it hit the ground. All right, one more. And let's see here. It says, suppose you are a police patrol officer and you have a 300-foot long roll of yellow do not cross barricade tape to seal off an automobile accident as shown in the illustration. Okay, so in this illustration, there's a couple of cars and they're all crashed. It's a big mess. Lovely drawing. Okay. What dimensions should you use to seal off the maximum rectangular area around the collision? And what is the maximum area? Okay, what do we know? We know that this thing is a rectangle because they tell us that. We know that we have 300 feet of yellow tape. We want to produce the maximum area of that rectangle to seal off the accident inside, all right? So the perimeter, the entire distance around it would be 300 feet. If I were to say, well, let's just look at half of this problem, okay? So if we're looking at just this piece and this piece, together those would equal 150 feet, right? Half of it. Now, let's say I've got two sides of a rectangle, okay? So here's our two sides of a rectangle. And that total distance is 150 feet. If I call this distance x, the whole thing's 150. If I call this one x, what's left? 150 minus x. So this becomes 150 minus x. Now, why do I need all of that? Because now I've got a value for the length and the width, all right? So to maximize the area, I'm going to use function notation. A of x equals the length times the width. Area equals length times width, area of a rectangle, okay? So A of x equals 150x minus x squared. A of x equals negative x squared plus 150x. Again, I'm putting it in standard form. Okay, now, x represents, let's see, we'll call this the width. And we'll call this the length. X represents the width of the rectangle. A represents the area. We're trying to maximize the area. Well, let's look at our equation. It has a leading coefficient of a -1, which means that the graph is going to be a parabola that opens downwards, okay? The vertex is going to be at x comma a of x, some value. The x value will be the width. The a of x value will be the maximum area. So again, it's all about the vertex, okay? Now, a is -1, b is 150, x equals negative b over 2a, negative 150 over 2 times -1, negative 150 over -2 is 75. So x is 75 feet, which means 150 minus x is also 75, right? 150 minus 75 is 75, okay? So we now have our dimensions, 75 by 75. The area, A of 75 would be, let's see here, using this, negative 75 squared plus 150 times 75 equals, calculator time, okay, negative 75 squared plus 150 times 75 is 5,625, and that would be square feet. So the vertex would be at 75 comma 5,625, okay? The dimensions would be 75 feet by 75 feet. And the maximum area, let's see, maximum area would be 5,625 square feet. Now, you need to be careful because in WebAssign, sometimes for their answers, they'll say smaller value, larger value. And I happen to know that this is a problem where they say that, and it's confusing because if it ends up being a square, your values are the same. So if you get values to be a square and it says smaller value, larger value, you're just going to put the same value in both places, okay? All right, that's what I have for today. I will be back, let's see, at 1:15 with an office hour. So tonight, your assignment is to finish up whatever you haven't done in 10.4, also the chapter 10 review. Tomorrow, we will have a review session for those that want. And then Monday, no class meeting, no Zoom class meeting, because Monday you'll just take your chapter 10 test to be finished Monday night by 11:59 p.m. So there you go. Bye-bye.